now to that very important question of what is BIM? BIM can be defined in two ways. So it's an acronym for Building Information Model, or a single source of truth. So a digital 3D representation of a building or an asset where all information regarding those components within that asset can be stored and shared. On the other hand, it's an acronym for Building Information Modeling, or the method of how we create, record, or collect information and share information and edit information for a built asset over the entire life cycle of that asset. At the very beginning of a project, one should always think about what information will be needed at the very end of the project for the operation and facility management, and even for the demolition of that built asset. This means we have to start at the end and define what information will be required and formulate these requirements from the project's outset. So in general, BIM represents a deep digitalization of the value chain from planning, building, all the way to operation and demolition. All parties involved in a BIM project belong to the planning process. The participants in a BIM project come from all sectors, so planning, construction, and real estate sectors, ranging from clients to planners to contractors and operators. A guiding principle to remember using this BIM method is to build digitally first and then build in reality. That means making mistakes in the digital model that we don't have to repeat in the real world. And that saves us a lot of time and money. BIM can be applied to any type of project regardless of the complexity or size. It is also independent of building typology. We can apply BIM in infrastructure projects as well as high-rise construction, residential projects, as well as hospitals. There are really no limits. A very important factor is that of collaboration. All work needs to be model-based and focused on information so that our team can make informed decisions based on that information. We need to adhere to standards as much as possible so that the data that is delivered is consistent and we don't have to reinvent new structures and processes every time. Now let's look at how a building information model is created and how it works. First, data must be recorded digitally. This means we assign attributes to a model or model's components that can then be further processed. For example, simply drawing a 2D plan and labeling each door manually is not digital and cannot be read by a machine. Instead, we define a door type in our model, and we do that once, including attributes like width and height. Then we place this component throughout the model, and our labels for this component will be read automatically and generated automatically. It's all about connecting data. So we can use models from all of the various disciplines in our construction process, and we can link those models and exchange information between those models. In traditional planning, there are often multiple disconnected data sources. For example, a 2D plan showing doors as lines and a separate Excel sheet listing doors manually. In a building information model, the doors are model components with properties. So door schedules can then be automatically generated. External information can also be integrated. For example, a fire protection engineer can update the fire resistance rating of doors directly in the model. Thus, all information is gathered in one place, creating a shared digital information environment where all participants contribute to and access the very latest data. In BIM, geometry and alphanumerical information come together in one space or in one package. For example, a door in the model is a geometric component that also includes attributes like the sound insulation or the acoustic properties of the door, the fire resistance properties, a manufacturer information, width and height as discussed, and that provides a single reliable source of information. To create building information models or to implement the BIM strategies in our organizations, certain prerequisites or key factors need to be considered. The most important being people. We need the necessary know-how and must define and align our processes. Those traditional workflows that we have in the conventional planning and construction processes cannot simply be forced into BIM. Oftentimes we have to rethink those processes. There are also standards and guidelines to follow. In Austria, we have the ÖNorm series of standards. In Germany, there's the VDI. In Switzerland, there's the SIA, for example. There are also international standards to follow, published from the ISO and from Building Smart. These define procedures and formats used in BIM projects. Another key factor is technology. We need the appropriate hardware and software to create and process and manage that model-based information. Often, one of these factors is overlooked, leading to poor results and poor implementation of the BIM method. Therefore, all of these factors have to be carefully considered. We'll start with people. Motivation is absolutely crucial. Even with the best tools and standards, if the team lacks motivation or buy-in from the leadership, BIM implementation can fail. Successful BIM adoption requires a cultural shift in our organizations, an openness to change, an openness to use and learn new technologies and new ways of working. Training and qualification are, of course, also critical to equip staff with the necessary skills and to reduce fear and resistance. Education helps people understand and confidently use these new methods. BIM projects rely heavily on teamwork and collaboration, and shared effort is essential. New roles also emerge, such as information managers responsible for managing, processing, and evaluating data. Organizations need to assess their competencies and maturity levels regarding information management to identify skill gaps and training needs. Reviewing past BIM use cases or pilot projects and planning accordingly. BIM changes collaboration fundamentally. Teams now work together on a central model, on a central server, or on cloud-based platforms. Communication also becomes model-based, using visualization tools to discuss specific issues, specific components, and even to track changes. At the project level, teams work transparently on shared platforms where all information and models are stored. The entire process is digitally driven, allowing efficient data exchange through standardized formats, such as IFC and point clouds. Proper information management and information requirements must be defined to ensure data quality. Another important factor to consider in implementing BIM are the standards and norms. There are certain norms that have already been published regarding BIM, such as the ISO 19650 series of standards, which focuses on information management using building information modeling. We also have national standards. In Austria, there are diverse Normen, like the Norm 6241 series of norms, which focus on creating and sharing information using building information modeling. In Germany, there's a series of standards and norms called the VDI 2552, in which multiple pages and multiple parts define and provide workflows for the BIM methodology. Classification systems such as the ENORM B1801, Omni Class, Master Format, DIN 276, these categorize building components for structured data analysis. There are also office-specific codes and standards to follow, such as internal modeling guidelines, defining how walls and floors and building stories should be modeled for consistency. These standards ensure all project participants speak the same language. Software and hardware are definitely required for BIM implementation. There's authoring software such as Revit or ArchiCAD or Allplan, in which we can model or create our models. There are different quality assurance tools, ensuring that our models include the relevant information, are modeled appropriately or correctly, tools that focus on time and cost or scheduling. And there are tools to be used on the construction site or manufacturing, and facility management tools as well. There are also collaboration platforms and communication platforms. As far as hardware technology, we need a relatively powerful computer to run all of these software programs. Mobile devices can be used for on-site access, and laser scanners can be used to capture existing conditions. VR or AR equipment can be used for immersive visualization or construction simulation. And even intelligent machinery or robots can integrate BIM data to avoid on-site errors. Here we see a vague or a basic implementation strategy. So we start with an inventory, where we define opportunities in our organization's information management maturity level. So an assessment of our current state. Then we define our strategy and goals, create an implementation plan. Then we'll need to define our processes and which processes will be required in order to carry out that implementation plan. Then we can select our tools and technical infrastructure and put those into place. Training plans need to be formed and conducted. And then, very important, we need a continual evaluation of our BIM maturity, our information management maturity, and we need to continually optimize our processes.